Nitrogen is everywhere. It's a fundamental building block of life. It makes up 78% of the atmosphere, and it's in these tiny microbubbles in my Starbucks Nitro cold brew. And yes, this episode is sponsored by Starbucks. They challenged me to liquefy nitrogen out of the air, and that's what I'm gonna be doing in this video. But first, I'm gonna try Nitro cold brew for the first time. It's subtly sweet without having to add sugar, and obviously it's cold and frothy. And I'm gonna explain why nitrogen makes this possible. But first, I'm gonna try to liquefy some nitrogen for myself out of this atmosphere. Come on, let's go. Okay, in order to make liquid nitrogen, we need a way to make the air really cold. And to do that, I'm gonna use this cryo cooler. So essentially what's inside here is a cylinder of helium and a couple pistons. So there's a piston that compresses the helium down into this section, and when it does that, it makes that gas really hot. And so that heat gets ejected to the surroundings through this heat sink. Then the helium is expanded down in here, and as that happens, it gets really cold, so it absorbs the heat from the surroundings. So this is the part of the cryo cooler that is gonna get down to less than minus 200 degrees Celsius. So cryogenic temperatures. This is the place where we can really liquefy some gas. So I want to put this to the test and first do a sort of simple proof of concept and make sure that this is working and just try to liquefy air. Liquefy the air in this room. This is Alan Pan. Alan is handier with tools than I am, so I brought him in to help me make this happen. How should people know you, Alan? Like, what do you get into? What's your thing?
I'm a failed Mythbuster, and also I have a YouTube channel called Sufficiently Advanced.
You may know Alan from his creations, and relevant to this project, shooting liquid nitrogen from his hands.
I'm definitely breaking your drill, by the way. That plastic is coming right off.
I see that.
Did I measure this correctly? Let's see. Does it go in and stop right there? Oh my God, look at that! Perfect!
So now let's turn it on, and you can listen, you can hear it turn on. Oh, the pump is starting.
It's purring.
This is the moment of truth. Been running the cryo cooler for about 4 hours. Hopefully getting some liquid air in there.
I bet you 50 bucks, there's at least 50 milliliters of liquid air in there.
50 milliliters. Sir?
That's not even that much.
It isn't even that much, but
like
I'll be amazed if it happens.
Oh, that's 50 milliliters right there.
I bring you a 50 milliliter beaker. Whoa.
Do you feel any sloshing?
Oof.
I hear something. I hear something. I hear something.
I can hear liquid. We have made liquid air.
That sounds like...
How much have we made?
50 milliliters.
Is that how much we've made?
Of liquid air.
Oh.
50! Oh! Dude, that's 50 milliliters of liquid air.
Oh. I know it doesn't look like much, but to make 50 milliliters of liquid air, we needed to condense around 35 liters of air from the room. What's funny to me is I've done a lot of experiments with liquid nitrogen, but this feels like the most precious liquefied gas that I've ever had because we made it ourselves. There was more than 50 mil in there.
I know we didn't shake on it, but you definitely owe me $50
I definitely do. Because that's impressive from just a few hours, you know, running it for the first time. Liquid oxygen is paramagnetic, which means it's attracted to permanent magnets. I'm gonna use this effect to try to extract some liquid oxygen. Something came up.
Oh, dude, you got it. You got some.
See that droplet at the end of the magnets? To make sure it really was liquid oxygen, we tested how it affected a flame.
Yeah. So that's for sure oxygen. That is liquid oxygen.
You can see how the matchstick reignites with the liquid oxygen, and the flame spreads towards the higher concentration of oxygen.
Oh.
There you go, we have made liquid air. Next step, remove the oxygen and just make liquid nitrogen. Okay, it is day 2 and time to scale up. We are moving the cryo cooler to a bigger stand.
Should I just go?
Yeah, go for it.
I'm putting a lot of sawdust into your carpet. I'm sorry.
It's okay, Alan. To To make pure nitrogen, we need pressurized air. So I've got an air compressor here in the garage. The pressure of this compressor is about 10 atmospheres, so I'm gonna pressurize this line here. Now the first thing we got in the line is a filter to remove water vapor. Now to get pure nitrogen, this is the key component. It is a nitrogen membrane. And what it actually contains is a bunch of hollow polymer fibers. And so we supply compressed air in this end, and all of the gas molecules try to diffuse out of those fibers because of that high pressure. But these polymer fibers are made out of a material that is selectively permeable. It allows oxygen and carbon dioxide and water vapor to diffuse out much faster than nitrogen. And so those gases actually come out preferentially through these holes. So what you're left with at the end is a high concentration of nitrogen. And to get the highest purity, what you need to do is have a very high pressure and a slow flow rate, because that gives a lot of time for those other gases to escape. Whoa. I don't know about this gauge. So what I want to call and watch is how long it takes to increase the pressure in the tank. Well, we worked it out yesterday and we figured out if it takes 6 minutes to fill the tank at 100 PSI, then we've got 98% pure nitrogen.
Cool, perfect.
Right, but we just have to be very slow with this tank filling, and I don't know if we are that slow. We're going to try to check the oxygen levels that have come through this membrane.
Let's put some money on it. How about $50 says the oxygen is less than 5%? Yeah?
Are you gonna bet that? Because
Yeah.
I will easily take that bet.
Yeah? Alright.
I don't think this went very well because that was the first filling of the tank. So we weren't high pressure going through the membrane. So I don't think it's gonna be
I think we're good. 95% nitrogen.
95% nitrogen. So this meter measures oxygen. So we're looking for a number less than 5%, which I suspect we will not see. Oh. Can you hear?
Oh, it's
Whoa.
going down!
Whoa.
It's going way
Whoa.
down! Come on, 5%! Oh! There it is!
Whoa. Here we go, 99.
99%, not over 99%, 99.2, 99.3.
I am shocked.
There's no oxygen in this air, baby. It's all nitrogen. 99.5.
I am so shocked right now.
So we're at $50 for the liquid air bet. We're at
Yeah.
$50.
Yeah, you
for
just
the
won yourself
oxygen.
$100. Look at that, 99.7.
Percent nitrogen.
This is insane. And you can understand why there would be an alarm if you were in a room with 0.3% oxygen.
Yeah. I knew it. I told you.
You knew this
Didn't
would
I tell
work.
you? Yes.
Okay, so we've achieved, I guess, the second part of this, which is isolating nitrogen from the atmosphere, and now we just have to
Get it super cold. What we gotta do is we gotta put this thing here.
For better insulation, we scaled up to a Dewar. That's impressive.
Kind of sci-fi, janky garage sci-fi kind of a look. Go ahead and lower that. It'll just squish right on.
I hope.
I mean, that's sealed, you know? I think, honestly, we could just turn it on and see if it works at this point.
Start bleeding some nitrogen in there so that when the nitrogen goes in there, it'll push out any remaining air that's still in the tank. I'm gonna switch on the Variac, which powers up the crowd cooler. The other thing I need is the fan.
Yes.
This is the fan. I'm gonna plug that in. That's a cooling fan for the crowd cooler. We're up to 8 watts.
Ooh.
Okay, I have been running the nitrogen setup for about 3 hours, and my concern, because the temperature on the thermocouple never got very low, was that I wasn't actually making any liquid nitrogen. So I've stopped the test, and I just want to see whether or not there is anything in here. Doesn't sound like it. Nothing. Huh. What I think could be part of the problem, I was putting nitrogen possibly at a rate that's too high. So this is effectively nitrogen coming in at room temperature, and I wonder if it was just too warm for it to ever reach the liquefying temperature right here at the end of the cold finger of the crowd cooler. So I feel like I need a slower flow rate, maybe a better way to introduce the nitrogen into the Dewar. Not as easy as I'd hoped. Okay, my plan is to go with a smaller flask, something like this, and we're gonna use its lid to make a nice tight seal, except we're gonna cut a hole through the top.
I think it's good enough for this cold finger.
All right, then we're gonna try to drill a hole in the side for the supply of nitrogen. We need to make nice tight seals around both of those things, so that is gonna be the challenge. This is the kind of the new design here that we've got. I feel like it's pretty good.
I think it's gonna work. I think you're gonna wake up and there's gonna be liquid nitrogen in there. I bet you $160 that there's liquid nitrogen in there.
I don't know if I'll take that bet. I'm gonna turn down the cryo cooler and let's see what we got. It looks cold.
Yeah, there's definitely some condensation. So there's something cold in there. What do you see? Oh! There's liquid nitrogen! There's like this much! That's liquid nitrogen!
We have some liquid nitrogen out of the air.
That was so much effort for like this much liquid nitrogen.
So what do you do with homemade liquid nitrogen? Well, make homemade ice cream. Just a bit of cream and sugar, and then the liquid nitrogen. The most precious liquid nitrogen I've ever had. Is it enough to make ice cream? Come have a look, have a look. That is delicious. By freezing everything so fast, because it is minus 196 Celsius, you get really small ice crystals, and so that gives the ice cream a really smooth flavor, smooth texture. In a lot of stores, Starbucks 2 generates nitrogen just out of the air because why not? It's an available resource. They purify it and then infuse it inline into the drink, creating millions of those tiny bubbles. And that gives it its unique texture. So nitrogen bubbles are much smaller than the bubbles you're normally used to, the carbon dioxide bubbles that you'd find in soda. And that gives this a sort of creamier texture. The other nice thing about nitrogen is that it's totally inert, so it doesn't react with the drink. CO2 reacts with water, creating some acid, which you might like in soda. You might want a little bit of a sour, tangy flavor, but you don't want that in coffee, hence the nitrogen. One thing I found really interesting when they were pouring this nitro cold brew is that you can actually see bubbles coming down on the sides of the glass. And that's strange because these bubbles are obviously less dense than the coffee. They should be rising up to the surface. So why are they doing that? Well, the answer is the nitrogen bubbles are rising up to the surface a lot in the center of the drink, and so that actually creates a current that pushes them down around the outside, and so that's why you see those bubbles cascading down at the beginning when you're pouring the nitro cold brew. So there you have it. Nitrogen is everywhere and useful for lots of things. If you want to try out a nitro cold brew, I'll put a link to order it down in the description. And thanks for watching.